Welcome to the project demonstration of hand gesture control home automation. So here we are going to control the home devices, like we are representing this bulb as a device 1 and this fan as a device 2. So it is a DC fan. So in order to control these devices, we need to provide the inputs. So in this model, we are going to provide the inputs from this gloves based on the hand movements. This gloves consists of MEMS accelerometer, that's ADXL 335, which will provide us the analog output in X direction and Y direction and Z direction. So when we tilt this sensor by mounting on this gloves, so when you are tilting this left side, right side and left side, it's X axis, and forward and backward is a Y axis. So when we are tilting it in X axis, the voltage increases and decreases. So for example, so when we place this in normal condition, it's parallel to earth, then it will provide us the 3.5 volts, and when we increasing the angle towards right side, then voltage will increase. When we are bending towards the left side, voltage decreases, and forward increment and backward decrement in Y axis. So we are connected this X and Y axis to A0 A1 pin of our PIC16F72 microcontroller. So here we set the voltage limit for 3.7, more than 3.7. It's accepting as Y axis inputs, sorry, X axis input in the right direction, and left side, if it is below the 3.3 volts, it's a X axis input for the left side. So right side, left side, and forward backward same for the Y axis pin also. So based on these conditions, means 1 2 3 4, so the 4 conditions, so we are going to transmit the 4 bits in terms of 2 pins. So pin 1 for X axis, pin 2 for Y axis, that is a B0 and B1. So let us assume B0 was connected for the X axis inputs and B1 was connected for the Y axis inputs. So when we are bending that, so B0 will provide us a 0 for left side, and right side B01 means 5 volt, means 0 volt 5 volt for X axis, means nothing but the B0, and forward 5 volt and backward 0 volts for the Y axis, that is the B1 pin. So that data, digital data input is connected to the RF transmitter here, that is connected to the D0 D1 pin of our encoder IC. From there the data will be encoded and transmitted through this RF transmitter, which is operating voltage at 430, operating frequency is 433 megahertz, operating voltage is 5 volts. So for that purpose we are providing 9 volts battery, though we need 5 volts power supply. So we place the 705 regulator over here, which will take 9 volts input, nothing but greater than 5 volts will be regulated to the 5 volts constant output. So when we provide that, it start reading input from the input MEMS sensor and provide us the output to this RF transmitter. So when that's D0 D1 data bits received by this RF receiver module, so that is a main input to the decoder IC. So where we are going to decode the data, again same data is the input to the relay board and transistor board. So on this relay board we can see the transistor and relay and LED indication and diode. So diode will act as a flyback diode, which will neutralize the harmonics generated by the electromagnetic relay. So here the switching sequences when we tilt it to the right side, for example, so the B0 is high, so D0 will be high, here D0 will be high, same is input to the relay, means transistor to relay, relay to the bulb. Same here also, D1 to the transistor to the DC fan. So here receiver section will getting power supply from the 230 volts AC to this regulated power supply board, which will take the 230 volts AC input and provide us a 12 volts DC output on after this transformation rectification, means transform to step down the 230 volts AC to 12 volts AC, and rectifier to convert the AC to pulsating DC, and filter to remove the pulses to get the pure DC voltage. But we need 5 volts power supply, as operating voltage for the receiver is a 5 volts. So for that purpose we will place the same 705 regulator under this PCB, so that is a DC output to this breadboard. So here the breadboard purpose is to distribute the 5 volts power supply to RF receiver board, to transistor board as a power supply to the fan, and 5 volts power supply to the relay to be controlled. and 230 volts parallelly given as input to this bulb through this electromagnetic relay. So let us see the demonstration. So before on this receiver, mount this gloves in the right hand as shown very gently, as these connections may get disconnected, so it will malfunctions. So you need to eliminate that. Right. Okay. Place the hand is parallel to it. Now connect the battery connector. So initially this LED will be on and off 2 times. So I'm placing it normal. So while placing it gentle, as it will get pressed, so don't hard press to the floor. Off. As previously I bended the right side, so that's why the device is off, on state only. On, off. As I discussed previously, so X plus X minus, so means B0 high, B0 low, parallelly D0 high, D0 low. Same thing for the forward also. Fan got switched on, as you can see the fan is rotating, and backward fan off, means Y plus Y minus. So parallelly B1 plus B1 minus, means B1 0, parallelly D1 0. Parallelly the transistor of that fan will get switched on. D1 low means D1 off. So both devices will be on at a time. So now the 2 devices are rotating. So if you want to off the device, any one of the devices, you can provide the same inputs. Sorry, Y minus means to off the device, X minus, right. So in this manner we can control the device. The main application of this project is we can use this for the physically challenged persons, those unable to move from the bed, and if they want to control their devices, their room devices, for example for lighting purpose, light or a heater we can place, and for fan purpose just we can place the DC fan, so that they can control the minimum devices. In future scope we can place the number of devices by adding the flex sensors to our hand, so that the persons can control the n number of devices by improving this version using the PIC microcontroller at the receiver end also.